In this video, we prove the product rule. Right, so up here, this is the product rule. It says that the derivative of the product of two functions f of x times g of x is equal to two terms. The first one is the derivative of f times the function g, and then the function f times the derivative of g. Or in another way, we can write it as f prime of x times g of x plus f of x times g prime of x. So why is this formula true? Let's prove it. First of all, we let a function capital F equals the product. Right? You're just giving f times g a new name called capital F. Then by the definition of derivative, we know that f prime of x, that is the derivative of f, is equal to the limit as h goes to 0 of f plus x plus h minus f of x divided by h. Now, so we put the expression of f into these two terms here. Therefore, we will get f prime of x equal the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x times g of x, the whole thing divided by h. So the next thing we're going to do is to expand this expression. How are we going to expand this expression? We're going to introduce a term which is not in there, and then we're going to take it out again. So how is this done? Let's write the first term down. So this is the first term. And then we're going to put two extra terms in the middle. First, we write minus f of x plus h times g of x. But since this term wasn't originally there, we're going to take it back. Plus f of x plus h times g of x. Right, so we haven't changed anything. We just minus this and plus this. The two will cancel. Finally, we have the original second term, this one, right? And the whole thing has to be divided by h. Next, we're just going to reorganize all this. Now, notice that these two terms have f of x plus h in factor. So we can take that out in factor. F of x plus h times g of x plus h minus g of x. Right? And then we're going to deal with the third and fourth terms in a similar way. In this third and fourth term, we have g of x in factor. So we're going to pull that out on the right side. So now we have two limits, but these are limits of products, and we're going to apply the product rule of limits. So how do we get from the top equation to the one below? We apply the product rule for limits. And that is going to give us this expression. Limit as h goes to 0 of f of x plus h times the limit of the second factor, which is g of x plus h minus g of x over h. Similarly, the second term becomes limit of what is in here in factor of the second term in factor. So we're going to have the limit of x plus h minus f of x over h times the limit as h goes to 0 of g of x. Now, so finally, what are we going to get? For the first limit, as h goes to 0, this is simple. We have f of x plus h, but if h goes to 0, then we get back f of x. That is the limit of the first term. We have to think of this as the limit as h goes to 0 of the first term. And the second term is simply by definition. What is the definition? This is precisely the definition of the derivative of g. So this is g prime of x. Similarly, we're going to see that the first factor here in the second term in this product, this is by definition the derivative of f. So that is f prime. And in the last term here, what is the limit of g of x as h goes to 0? Well, in here, in g of x, there's no h at all, so it doesn't change whether h goes to 0 or not. So in particular, as h goes to 0, it will always be g of x. So in fact, this is always equal to g of x. So there you have it. Now we have the formula, tidy it up. It's precisely what I wrote here, so I just remove the second term back to the front, and the first term to the back. That's how we write it usually. Right, so this proves that the derivative of capital F, which means that the derivative of f times small f times g, is equal to f prime g plus f g prime. So this proves the product rule of derivatives.